Welcome to this Cresset web clip where I will introduce Activity Atlas for capturing and communicating regions of structure-activity relationship. Activity Atlas uses a grid across the aligned molecules to investigate how the molecules change and to relate this back to primary activity. At each grid point, Activity Atlas calculates the change in electrostatics, shape, and hydrophobicities between each pair of molecules and weights this change by the change in activity. This creates the regions where the structure-activity relationship is most sharp using three-dimensional activity cliffs. The grid is also used to study the properties of active molecules in order to create a picture of the average active molecule in terms of charge, shape, and hydrophobic features. Finally, all the molecules in the dataset are used to build a description of the regions of space that have been fully explored in terms of positive and negative electrostatics, shape, and hydrophobicity. I've opened a dataset of DPP-4 inhibitors in Forge. This dataset was aligned previously using field-based alignment and scored using 50% fields, 50% shape. To create an Activity Atlas model, press the Process button on the top row of buttons in the Forge window. In the panel, let's choose to not do the confirmation hunt and not do the alignment, since these have already been done. In the Build Model drop-down, choose Activity Atlas. That's all that's necessary to start the calculation. If I wanted to change the individual options, then clicking Show Options gives the longer form of the window. Looking at the options for how the Activity Atlas models are calculated, it can be seen that by default it uses a grid spacing of 1 angstrom, and that the ranges for what are considered meaningful values for disparity, activity, and alignment score are automatically calculated. Pressing Start gets the calculation underway. It is easier to visualize the Activity Atlas models with a molecule present to orientate us. Here I will sort the table on activity and use the most active molecule. The graphical plotting of the activity cliff summary shows where the model implies that certain modifications can be made that may result in increased activity. I turn this on by using the Model button on the right-hand button bar, or by using the QSAR Model dock with the 3D View tab. All colors can be customized to the user preferences. In the default color scheme, the current model suggests that it would be favorable to put something negative in the areas shown in blue, positive in the areas that are red, and hydrophobic in the areas shown in green. The most dominant feature in the model is the benzyl side chain, but I'm going to concentrate on the SAR of the right-hand phenyl group. Activity Atlas suggests that the substituting at the 2 position is favorable, while there is some steric hindrance in the 4 position. Unusually, the model indicates that making the face of the aromatic ring more positive is associated with increased activity. That is, I want to add electron withdrawing groups, such as the 3 fluorine atoms in this, the most active molecule. Note that in the activity cliff summary, the primary amine is not showing as being important. This is because it is present in both actives and inactives. To complement these activity cliff views, I will use the average of actives views. Turn off the activity cliff summary and turn on the average electrostatics and average hydrophobics of active molecules. Red regions are positive, blue are negative, and orange is hydrophobic. The plot seen is a profile for what an active molecule looks like according to the Activity Atlas model. Now it is seen that a positive charge dominates the lower half of the molecule, but also that the most actives have a hydrogen bond acceptor in the top left corner and at the back. Finally, Activity Atlas reports the regions that have been fully explored to give an idea of what chemical space has been examined and where I could explore further. This map, in conjunction with the information from the activity cliff summaries and average active profile map, can be used to assist design efforts to push for more active molecules or for molecules that make new interactions. If I view the shape explored, together with all of the molecules in the dataset, I can see that there is a single compound that enters space at the bottom that has not been fully explored. This could be an opportunity. Building activity atlas models can provide better understanding and visualization of structure activity data, especially for datasets that have structural diversity. It can be used to help learn what active molecules have in common, what the activity cliffs imply in terms of driving activity, and what regions of chemical space have been explored. If you have any questions or would like additional information regarding Activity Atlas and SAR elucidation, please contact us by emailing support@cresset-group.com.